Okay, so here we are, section 8.3, special right triangles. Um, this is a section, it's mostly tricks and memorization, but stuff that you're going to need, and you're going to use it all the time in Algebra 2 for Chapter 13 when you do trig. No, wait, 12, whatever it is. And then you'll do it all the time in pre-calculus if you've never taken pre-calc. It's a section you use quite a bit. Um, we've talked about isosceles and equilateral triangles. Today we're going to talk about the 45, 45, 90 and the 30, 60, 90. Now, first thing is the 45, 45, 90. It comes from a square. That's kind of the idea of why is this one so special. Well, what someone thought is like, hey, let's take a square and cut it in half. And then they used the Pythagorean theorem to solve for missing sides. So I'm just going to walk you through that real quick. So they said, okay, well, this side here we'll call it x. We'll call this side x here. The question is, what's the hypotenuse? Well, the hypotenuse is really the diagonal of this square. So Pythagorean theorem, leg squared plus leg squared is hypotenuse squared. Okay. And then x squared plus x squared is 2x squared. To solve for both sides, take the square root. Now here's the thing that's kind of crazy is x times x is what x squared is. So I get to bring an x out front. But that 2 is stuck inside because there's nothing to pair up with. And the square root of c squared is c. So what someone realized is, hey, if you have a right triangle and the two legs are congruent, or we now actually name it by the angles, both of the angles are 45-degree angles because that's what happened when you cut a square in half. This is 45 and this is also 45, and this is 90 over here. You get a right triangle where it's x for the legs, and the hypotenuse is just whatever that leg length is times root 2. So that is the 45, 45, 90 rule. So in a 45, 45, 90 degree triangle, the legs L, and that's what the book uses, it uses the letter L. I've always used the letter X, but I'll do the best I can to keep up with the L. If the legs are congruent and the length of the hypotenuse is H, that H is root 2 times the length of the leg. So if it's 45, 45, 90, take the legs, multiply by root 2, that gives you the hypotenuse. So here are a couple just kind of quick examples to run through for that. Okay, so here's the first one. Okay. So you've got leg, leg, and here's the other thing about this one to recognize it is, it's also for isosceles right triangles. So they won't always tell you 45 and 45, they'll just say 5, 5x, and they expect you to go, oh, well, that's isosceles, it's a right triangle, meaning these guys are both 45 degrees because the hypotenuse is 90. So to go from the leg to the hypotenuse, the quick trick is take the leg, that's L, this is L here, the hypotenuse is L root 2, so take the leg and multiply by root 2, or 5 root 2. That's it. Kind of like the Pythagorean triples, the whole point of this is to make the process a little quicker. Okay. Now, 1C, okay, is the same exact idea. You've got 45 degrees here, they've got this is x, they've got this leg as 7 root 2. What they're expecting you to recognize is that, oh, well, the other angle then for this guy must be 45 degrees, meaning this leg is also 7 root 2. And then, oh, it's a 45, 45, 90, where this is L, this is L, this is L root 2. Okay. So the trick then is take the leg, multiply by a root 2. Okay. Now what ends up happening is I can multiply radicals together. So root 2 times root 2 is really root 4. So 7 times root 4. Well, root 4 is really 2. So this guy ends up being 14 for the hypotenuse. Okay, so, and again, it's just memorization and then some arithmetic skills. Okay, so let's look at C then. Sorry, I just did C. Let's look at 2A. 2A this time, we're looking to actually work backwards from the hypotenuse. So that's how 2A and 2B work. So this time we know the hypotenuse. What I don't know is I don't know the legs. So here's what I do. And it's what I was doing in the last examples, I never explicitly said it. I know the legs are both L. I know the hypotenuse is L root 2. So what I want to figure out is, what in the heck is the leg. So in order to do that, well, you'll tell me. Okay, so here we are, we're back. Hopefully you got that x was 5. Now, some of you might have just been savvy enough to recognize it, that, oh yeah, if this is 5 root 2 and this is L root 2, L has to be 5. But what I do, especially when we get to the more complicated ones, is I just think through it algebraically. It's 5 times root 2, it's L times root 2, so divide both sides by root 2. What ends up happening is we get 5 equals L. Oh, well, if 5 is L, both those legs then have to be 5. So really, x equals 5. That's our side length. Okay. Next example then. This one's the more complicated of the two. Okay. We're still working with the 45, 45, 90 degree triangle. But this time, this time like the last one, I have the hypotenuse. So this guy is the L root 2. I want to know what's the L, because again this would be 45. So this is where it gets tougher at. We have to go back to some of those rules from Algebra 1 with arithmetic and radicals. So L root 2 equals 18. I'm going to divide by a root 2. So it's 18 over root 2 for L. Now, we haven't done this for a bit, but in order to simplify division with the radical, we multiply the top and bottom by the radical. And the reason is it's this old arcane skill that we can't leave a radical in the denominator, we got to simplify it. So multiply the top and bottom by root 2, it gives me 18 times root 2 on top. And then root 2 times root 2 is really root 4, which is 2. Okay. And now 18 divided by 2, well, that's 9. So L is really 9 root 2, which that's x, so we could just say, okay, x equals 9 root 2. Okay. All right, so that one's a little trickier because you're dividing by root 2 still, but we have this little old-fashioned rule of don't leave a radical in the denominator, so multiply the top and bottom by that radical, therefore simplifying the denominator, and then it cancels. So yeah. Now, the next type of triangle is what we call the 30, 60, 90 triangle. And you can see it here, 30, 60, and then the right angle for 90. And how this one works, I'm just going to walk you through it real quick because there's a lot to do for this. How this one works is somebody savvy, really smart, said, let's make all the side lengths 2x. And what happens is when I draw in, because that's a 60, 60, and then this angle here is all 60. It's just 30 and 30 broken up. Well, if I cut this in half, this is the altitude. It's also the bisector of this side and the bisector of this angle. So if I make this 2x, this gets cut in half, this guy becomes x, because it was originally 2x for that side. So now the real trick is, well, what would this height inside here be? Because if I do that, I have a 30, 60, and then hypotenuse for 90 degree triangle here. So hey, this is the Pythagorean theorem. A squared plus x squared equals 2x quantity squared. Well, we have a squared plus x squared equals 2 squared, which is 4, x squared, which is x squared. And then I got to solve for a squared, so subtract an x squared. When I do that, I get 3x squared. And then I take the square root of both sides. And just like before, the x squared is the square root of x, but the 3 is stuck inside, so it's x root 3. And this is the more complicated of the two. So here's the theorem. You have a 30, 60, 90 triangle. Okay. The hypotenuse is 2 times the length of the shorter leg, s. S is across from the 60. And the length of the longer leg, L, which is opposite the 60, is just the shorter leg times root 3. So what ends up happening is we had this equilateral triangle we started off with. It's cut in half across the bottom. So 2x, 2x, x, x, because that's 2x total. So the shorter leg is half of the hypotenuse, and then the longer leg, which is really the altitude, is the shorter leg times a root 3. So 3a is the first example I want to take a look at, working backwards. And this is actually the hardest that this problem gets. It's weird. I just realized this now. The book went to the hardest one they could actually throw at you. So in 3a, we have to identify what do we have? Well, we have, in this problem, we have the 60 leg. That's what we have. This is the one opposite the 60 degree. Well, opposite the 60 is the L root 3 leg. Is that what they call the variable y's? No, sorry, they did S. Doesn't matter though, really. Okay, so to be consistent with the book, it's the S root 3 leg. The 30 is the S. The hypotenuse is 2S. So we need to figure out then is what's S, because if I double it, I've got the hypotenuse, and if I keep S, I've got X. So 12 equals S times root 3. Now here's why this is the hardest. I'm going to have to divide by a root 3 to get to S. So I have to do 12 over square root of 3, and then I have to rationalize that, which is times root 3 over root 3. That gives me 12 times root 3 on top. Root 3 times root 3 is root 9, which is really 3. And then 12 divided by 3 becomes 4 root 3. Now again, that's S though. That's the part that a lot of people always forget, is which one do I have? Well, on this one I solved for S. So since I solved for S being this number, hey, that's really X. Okay. And then to get to Y, it's double S, because that's what the hypotenuse is. So it's 2 times 4 root 3. So 2 times 4 then, and that's all I'm multiplying, it's just the whole numbers on the outside, is 8 root 3. That's Y. Okay. And again, I didn't realize it until just now, they gave you the hardest one first. If you can handle this one, you can do any of the 30, 60, 90s, because they're all the exact same thing. It's just, you know, which one do I have first and working that way. Okay, so 3b then. 3b, this one, again, this one's cake compared to that last one. So I have this triangle. So I have to recognize, what do I have? Well, I have the 10, which what's 10? Hey, that's the hypotenuse. That's 2s. I don't know the 60, which is the S root 3 side. I don't know the 30 either, which is just the S side. So again, like all the other ones, your goal is to solve for S first. Well, that's easy to do. If 10 equals 2S, divide by 2, S is 5, which means that I know that X equals 5. And then to find Y, well, Y is just whatever the S length is times root 3, so 5 root 3. And I'm writing my 5's kind of funny because my 5's looking an awful lot like an S to begin with, and I don't want you thinking, oh, just S root 3 for all, or S. No, this is S, this is a 5, so I apologize for my poor penmanship. Yeah. Okay, now the last one then, sorry, just a second. Okay, now the last one, 3C. This one is actually the easiest of all. So that's what's going to pop up. So real quick, I'll throw up a screen there. It'll ask you what's the length of X. What do you think it is? Okay, and then there'll be one here. It says, what do you think the length of Y is? All right, so let's try this now. Let's try this. So we look at this one, we have to say to ourselves, okay, what do we have? Well, I have the side opposite the 30. Well, what's opposite the 30? S. Opposite the hypotenuse is 2S. Opposite the 60 is S root 3. Well, that makes finding X really easy, because if this is S, double it for X. X is 42. And then to go to Y, all I do is take whatever S is and multiply by root 3. Well, that's just 21 times root 3. That's also nice and easy. Okay, so yeah, so there's a lot there, but we'll do a lot of quick examples. And again, it's just a lot of memorization and kind of getting some tricks down. So hopefully this made enough sense that tomorrow in class we're at a good place to start.